Happy morning, students. Coming back to the continuation of theorem 8.4. In a parallelogram, prove that opposite angles are equal. Let us draw a parallelogram ABCD. We need to prove that the opposite angles are equal to each other. That is, I want to show angle A is equal to angle C and angle B is equivalent to angle D. Now coming to the solution, given ABCD is a parallelogram in which the opposite sides are parallel. So AB is parallel to CD and AD is parallel to BC by the property of the parallelogram. To prove angle B is equal to angle D, angle A is equal to angle C. So we are doing the construction join AC diagonal. Let us consider triangle ABC and triangle CDA. We know that AB is parallel to CD and AC is a transversal. So I can connect the alternate interior angles are equal, where my alternate interior angles will be angle BAC and angle DCA. I am just marking those angles as angle 1 and angle 2. So I am writing here in triangle ABC and triangle CDA, we have AB is parallel to CD and AC as a transversal which cuts the parallel line. So I can show angle 1 is equal to angle 2. Similarly, taking BC is parallel to AD and AC is a transversal, cuts a parallel line, we can have the alternate interior angles as BCA and DAC, where I am marking those angles as angle 3 and angle 4. So coming to this, BC is parallel to AD and AC cuts the parallel lines. So we have angle 3 is equal to angle 4 by alternate interior angles. So I got two angles which are involved in the triangle ABC and CDA. Then we find that AC is a common side to both the triangles. So these two angles lies on the common side AC. So I can use ASA congruence rule. Triangle ABC is congruent to triangle CDA. So I can prove that angle B is equal to angle D by CPCT, since these two angles are involved in the congruent triangles ABC and triangle CDA. Now second case, I want to prove that angle A is equivalent to angle C. Now coming to the solution, we want to prove angle A is equal to angle C. We already proved that angle 1 is equal to angle 2, angle 3 is equal to angle 4 by using the alternate interior angles are equal property. So I am going to add those two equations now. So I am adding angle 1 with angle 4 and angle 2 with angle 3. So I am writing here angle 1 plus 4 and angle 2 plus 3. If equals are added to the equals, then the wholes are equal to each other. So I get angle 1 plus 4 is equal to angle 2 plus 3. So in the figure, my angle 1 plus angle 4 represents my angle A and angle 2 plus angle 3 represents my angle C. Hence I proved that angle A is equal to angle C. Coming to theorem 8.5, if in a quadrilateral each pair of opposite angles are equal, then the quadrilateral gets the shape of a parallelogram. We are drawing a quadrilateral ABCD. So we are going to prove that if in a quadrilateral we find angle A is equal to angle C and angle B is equal to angle D, then the quadrilateral ABCD gets the shape of the parallelogram. So I want to prove that ABCD is a parallelogram. Coming to the proof of theorem 8.5, given a quadrilateral ABCD in which the opposite angles are equal, so I am writing angle A is equal to angle C, angle B is equal to angle D. I want to prove that this quadrilateral ABCD is a parallelogram. So we are going to the proof of this theorem. So we are writing angle A is equal to angle C and angle B is equal to angle D, which is given in the statement. I am going to add angle A with angle B and angle C with angle D from these two equations. So I will be writing angle A plus angle B and angle C plus angle D. If equals are added to equals, then the wholes are equal to each other. So I got angle A plus B is equal to angle C plus angle D. Now I am going to use the angle sum property of a quadrilateral, where we know that the sum of four angles in a quadrilateral equals 360 degree. So I am writing angle A plus angle B plus angle C plus angle D is equal to 360 degree. And in the previous step, angle A plus B is equal to angle C plus D. So I am going to substitute, instead of C plus D, I am going to substitute angle A plus B. So I will be getting angle A plus angle B. Again I am going to write angle A plus angle B is equal to 360 degree. So I will be getting 2 times of angle A plus 2 times of angle B is equal to 360 degree. Take the 2 commonly outside. So I will be getting 2 into A plus B, which is equal to 360 degree. So I will be getting angle A plus B is equal to 360 divided by 2, which is equal to 180 degree. We have shown already in the previous step, angle A plus B is equal to angle C plus D. So my angle C plus angle D will also be equivalent to 180 degree. Now coming to the figure, going to take the sides BC and AD, and AB is a transversal, and already we proved that angle A plus B is equivalent to 180 degree. So I am going to use the co-interior angle concept, stating that when two lines BC and AD are cut by the transversal AB, making a co-interior angle sum is 180, then the two lines drawn are parallel to each other. So here I got BC is parallel to AD. Similarly, I want to show that AB is parallel to CD. So again we are taking the opposite angles were equal. Angle A is equal to angle C, angle B is equal to angle D. Now I am going to add angle A with angle D, angle C with angle B now. Equals are added to equals, then the wholes become equal. So I get angle A plus angle D, which will be equivalent to angle B plus angle C. Now I am going to use the angle sum property here. So here instead of angle B plus C, I am going to replace it as angle A plus D. So the same procedure we follow here. So using this procedure, I will be getting 2 times of angle A plus D is equal to 360 degree. So my angle A plus D is equivalent to 360 divided by 2, which becomes 180 degree. Now I am going to take the lines DC and AB. Similarly here, when DC and AB are cut by the transversal AD, and already in the previous step we proved that angle A plus angle D is equal to 180 degree. So I am going to use this with the co-interior concept. So coming to the solution, segments DC and AB are cut by the transversal DA, making co-interior angle sum is 180. So in AB is parallel to CD. We have proved that AB is parallel to CD and AD is parallel to BC. So hence the quadrilateral ABCD becomes a parallelogram. Theorem 8.6. The diagonals of a parallelogram bisect each other. So he has given a parallelogram ABCD. We want to prove that the diagonals bisect each other, which means that we want to prove OA length is equivalent to OC length, B length is equivalent to OD length. Coming to the solution, given ABCD is a parallelogram in which AB is parallel to CD and BC is parallel to AD, and the diagonals AC and BD intersect at O. To prove OA is equal to OC and OB is equal to OD. So let us consider triangle AOB and COD. We are marking angle OAB as angle 1 and OBA as angle 3 and OCD as angle 2 and ODC as angle 4. Now coming to the solution, in triangle AOB and triangle COD, we have AB is equal to CD because they form the opposite sides of the parallelogram, where AB and CD are involved in the triangle AOB and COD. Next case, AB is parallel to CD and AC is a transversal. I can relate angle 1 is equal to angle 2. That is, AB is parallel to CD and AC is a transversal. We get angle 1 is equal to angle 2 by the alternate interior angles. Similarly, AB is parallel to CD and DB as a transversal. I can relate angle 3 and angle 4 as alternate interior angles. So I am writing angle 3 and angle 4. So I got two angles on one side involved in the triangles AOB and COD. So by ASA congruence rule, triangle AOB is congruent to triangle COD. Hence I got OA is equal to OC, OB is equal to OD. So these sides forms the corresponding sides of the two triangles AOB and COD. So I can relate by CPCT. OA is equal to OC, OB is equal to OD. Hence we proved that the diagonals of the parallelogram bisect each other.